Lesson 12.3 starts dealing exclusively with probability, or should I say probability and odds. And first we're going to be looking just at the probability. Now probability is when we compare our successful possibilities to the total possibilities. So if I toss a coin in the air and I want heads, well, there's only one way to get heads. That's if you toss it and it lands on heads. How many possibilities are there? Well, there's heads or tails. So there's 2 total possibilities for it. So in the end, we'd say that the probability is 1/2, 1/2, or we could write that as 0.5 as a decimal, or we could write 50%. There's a 50% chance that you would toss a coin in the air and get heads. So that's how probability works, and that's going to be a little bit, it'll be similar but a little bit different to odds, and I'll tell you about that when we get to odds. So we're going to look at a larger example here. When we have 3 coins tossed in the air, what is the probability that we get all 3 as heads? So again, probability is the successful ways to do it versus the total ways to do it. So we're going to make a tree diagram. This is going to be where our first toss is, our second toss, and our third toss. So if our first toss is a heads, then our next toss could either be heads or tails, in which case our third toss could either be heads or tails. Again, that's if we had heads, heads, heads or tails. This would be if we have heads, tails, then heads or tails. That'll leave us a little more room to work here. Oh, a little much. There we go. Now if we had tails as our first one, heads as our second, we'll draw a little line there, then heads or tails our first one, tails our second one, then heads or tails as our last one. So this tree depicts all the possibilities that we would have of tossing 3 coins in the air, which one, all the possibilities of what they could produce. So we might as well just try them all out, write them all down. It looks like in this first case, this is the only place that we get what we wanted. It said we were looking for what would happen or how could we get all 3 as heads. So we've got one case here where we'd have heads, heads, heads. That's one way to write it down. If we had heads, heads, tails, heads, heads, tails, that's another case. Or we could have heads, tails, heads. Or we could have heads, tails, tails. So those are the only 4 possibilities when we're looking at heads as our first one. What if our first one was a tails? Well, then we would have tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. And like I said, there was only the one case where we got what we were looking for, all 3 of them being heads. So if we count them up, looks like we have 1, 2, 3, 4, 5, 6, 7, 8 possibilities, 8 total. That's what we'd put on bottom. And there's only one way to make it work the way we want it to, so we'd say 1 out of 8 is our possibility, or our probability is 1/8. Or we could rewrite that in decimal form as 0.125. That's another way to look at it. Or if we wanted to talk about percent, we would say that that's 12.5%. So when you toss 3 coins in the air, there's a 12.5% that all 3 of them will end up being heads. Probability with combinations makes things a little bit more tricky. So let's look at an example real quick here about Roman has a collection of 26 books. Good job, Roman. 16 are fiction and 10 are nonfiction. He randomly chooses 8 books to take with him on vacation. What is the probability that he chooses 4 fiction and 4 nonfiction out of that total 26? So there's going to be kind of multiple steps to this one. We know that the total number of books is 26 and that he's only taking 8, and we want to know how many ways are there or what's the probability that we'll end up with 4 as fiction and 4 as nonfiction. So we'll have to look at our probability is going to be, if we have the ways of selecting for fiction and for nonfiction. This "and" is kind of important there. As well, we need the total ways of selecting 8 books. So we have a couple different things to be looking at. If we want to look at the ways of selecting 4 fiction books, remember we said that there are 16 fiction books total, and it doesn't matter what order. You could grab Harry Potter 1, 3, 7, and 2, or you could grab Harry Potter 2, 7, 1, and 3. It's the same ones. So the order of the books doesn't matter, but they do all need to be 4 nonfictions, or how many ways can we select 4 nonfictions. So this one is actually going to be a combination, something we learned about in our last lesson here. So there are going to be 16 fiction total, and we just need 4. When we have this "and" in the middle here, that means multiply. In this case, when we're talking about probability, an "and" would mean multiply. So we have combination of 16 over 4, and in this case we have 4 nonfictions. Again, doesn't matter the order, so it's a combination 10 nonfiction total, and we just need 4 of them. So our numerator, the ways of selecting 4 fiction and 4 nonfiction, is going to be these 2 combinations figured out and then multiplied. Well, combination 16 over 4, remember that would just be 16 factorial over 16 minus 4 factorial times 4 factorial. So in the end, that's going to give us 1,820. Similarly, the combination 10 over 8, I'm not going to write the whole thing out, but it's going to come out to equaling 210. So we just do 1,820 times 210, and in the end that's going to give us 382,200. So this is how many ways we can select 4 fiction and 4 nonfiction. Now over here, we're looking at the ways of selecting 8 books total. So it's a combination, remember, because it doesn't matter the order. 26 total available, and we're picking 8. So how many ways can we pick 8 out of 26? So again, that would be the 26 factorial over 26 minus 8 factorial times 8 factorial, this whole piece, which in the end is going to give us 1,562,275. So it looks like, going back to this piece, we know that our top, the numerator there, is 382,200. Our denominator is 1,562,275. So we can leave our probability in this form, or we could say that if we, well, first off, if we wanted to reduce it, that would go down to 1,176 over 4,807. If we wanted to get that into a decimal format, we could round that to 0.2446, or if we wanted a percent, we'd say it's 24.46%. So almost 25% of the time, if you select 8 books out of 26, with 16 being nonfiction and 16 being fiction and 10 being nonfiction, almost 25% of the time you'll get 4 of each. Pretty cool. Now we will talk about odds. Odds differ from probability because where probability, remember we said it was success to total, odds are success to unsuccessful. So we have to find how many ways to make it work versus how many ways it doesn't work. So in this example, according to the United States National Center for Health Statistics, the chances of a male being born in 1990 living to be at least 65 years of age are about 1 in 3, or 3 in 4. Why did I say 1 in 3? 3 in 4. So we could rewrite that probability as 3/4. For females, chances are about 17 in 20. So we could rewrite that as 17 over 20. So that means that out of 20 females, 17 of them will live that long, which means if 17 live, then we would say that 3 out of 20 will die, unfortunately. This is a pretty morbid example. And we know this to be true because if we take the probability of our two events, living and dying, that would give us 20/20ths, which equals 1, or we could say 100%. So as long as they add back up to 1, those probabilities are true. Those are the two possible probabilities. All the probabilities of different events should add back up to 100%. Same thing here. If we have 3 out of 4 being alive for the males, then 1 out of 4 will die. And we know that's true because if we add these, go right across, it'd be 4 out of 4 again, or 100%. So if we know our probabilities, we'd say what are the odds that a male born in 1990 will die before the age of 65? So these ones are kind of tricky because if it's asking will die, that means our successful is the die. And we said that would be 1 out of every 4. So we would say 1 will die, and our unsuccessful then would be if you live. That would be our quote-unquote unsuccessful statistic, and that was 3. So we would say 1 to 3 are your chances. You can either write odds as this, a number, 2, another number, 1, 2, 3, or you can write it as kind of similar to how we had probability in that fractional form, 1/3. I tend to write them as 1 to 3 just because odds make more sense to me saying 1 to 3 instead of 1/3. Similarly down here, we have the odds that a female born in 1990 will die. So successful means death, die. Remember that was 3 out of 20. So our success is 3. And we want odds, so it's going to be 3 to some number. And we were looking at, if this one was die, then we're looking at live, which is 17. So 3 to 17. Those are a female's odds of dying, 3 to 17. Crazy, crazy odds. Probability distributions. So when we look at a graph, such as the one below here, this will show all of the probabilities and how often they occur given our certain situation or our certain event. So it looks like this event is when we roll 2 dice or 2 die and we add them together. So the smallest outcome that we can get, as we see, is 2, and that would be if we rolled a 1 and a 1 or snake eyes. We would get 2. If we rolled 2 6s, that would add up to 12. So that would be this mark over here. So this table has already been made for us to show what is a probability given that sum. So what is our probability of rolling a 2? Well, 1 out of 36 times we should roll a 2. What is our probability of rolling a 9? 1 out of 9 times we should get a 9. So using the graph, we want to determine which outcomes are least likely. So which ones have the smallest probability? Well, those are probably going to be the ones on the ends. And if you look at the graph, you can tell because those are the shortest of all of the bars on the end. So we would say the least likely ones are going to be 2 and 12. And then it asks, what is their probability? Well, their probability, as you can see on their table, is 1/36. Sorry, that's so small. It's 1/36 is the probability to get that. Now use the table to find the probability that the sum equals 11. So when we have p parentheses something, that's the probability of this happening. So the probability of the sum equaling 11. Well, we just go right to our table and we find where our sum is 11, and we need to know the probability. So we just look down here and we say, oh, well, the probability of probability of the sum equaling 11 is going to be 1/18, or 1 over 18. Then it asks, what sum has the same probability? Well, over here I see another 1 over 18, so that would be 3. So 11 and 3 are going to be just as probable, or just as likely to happen when we're rolling dice. Now it says, what are the odds of rolling a sum of 5? So I'm going to clear some of this out of our way here. If we look at our sum of 5, our probability, so when sum equals 5, probability, or should I say probability sum equals 5, is going to be equal to 1/9. But we're looking for the odds, which means that the probability that it's not going to be 5, so we could actually write that as probability sum not equaling 5 would be 8 out of 9. So if the probability we'll roll at 5 is 1 out of 9 times we should get it, then the probability that we don't get a 5 should be 8 out of 9 times that we will get it, because those will add back up to 9 out of 9, or 100%. So if we know our successful ways of getting 5 is 1 out of 9, and our non-successful ways is 8, we would say that our odds are 1 to 8. And that is how we would deal with probability and odds distribution. Make sure you're asking questions on probability and odds if you're not understanding any of this. Otherwise, remember to stay golden.